Okay, so in this chapter, one process that I'll follow every day while teaching is that, since this is a new topic for you all, every time I start teaching, last class जो पढ़ाया था एटलीस्ट फॉर्मूलाज में लिखता जाऊंगा, ठीक है? अब तक आप जो चीज पढ़ चुके हैं, चार्ज ऑफ एन इलेक्ट्रॉन इज इक्वल टू 1.6 into 10 to the power minus 19 coulomb. Okay, we are just using the magnitude of the charge. Then the formula for current is given as Q over T, where Q is measured in coulomb, P is measured in second, and then I is measured in ampere. ये आप एक पढ़ चुके हैं. Then to measure current, you use a device which is known as ammeter, and the ammeter is always connected in series, and an ammeter has low, very low resistance. ठीक है, इतना हम पढ़ चुके हैं. ठीक है, आज थोड़े से करंट के एक दो प्रॉब्लम्स हैं, कर लेते हैं, करके आगे बढ़ेंगे. ठीक है, वेरी इजी प्रॉब्लम्स. So it says, it's like this: an electric bulb draws the current. So let's say the problem is something like this. So given data, rather than given, let me try and explain you in this manner. So we have got an electric bulb. Let's say this is a bulb, and this bulb is drawing current. Okay, it is drawing current. So how much current does the bulb draw? The bulb is drawing 0.25 amperes. 0.25 amperes the bulb is drawing, and is drawing this when the bulb is running for 20 minutes. ये schematics बनाई है, तब आपको प्रॉब्लम करना आसान होगा. फॉर्मूला से प्रॉब्लम नहीं बनते हैं. 20 minutes, calculate the amount of electric charge that flows through it. So we need to find out how much of charge is actually flowing through it. Okay, right, how much of charge is flowing through it. So given क्या क्या है हमें, start again. I'll show you procedure. Current that is gone is I, which is given as 0.25 amperes, right? The time is denoted as T, which is equal to 20 minutes, and 20 means, very good, 6 into 2, 1200 seconds. And to find the charge, and charge is given by Q. Now you can write your formula, whatever you want to write. I is equal to Q over T, or Q is equal to IT, right? So substituting, you get Q is equal to 0.25. 0.25. 0.25 is equal to how much? 1/4. कहाँ हाथ में क्यों लिख रहे हो? You can write it as 1/4 ampere. So your calculation becomes easy. Into 1200 seconds. ये आपको कूलम दे देगा. Did you understand what I did? 0.25 को मल्टीप्लाई करना is same as 1/4 को मल्टीप्लाई करना. 1/4 को मल्टीप्लाई आप ज्यादा इजी से करोगे. So Q कितना हो गया हमारा? 4 3s are 12, 2 double zeros. तो 300 coulombs of charge has passed through it. ऐसे आसान प्रॉब्लम आते भी हैं एग्जाम में. इसमें कुछ नहीं, सब्स्टिट्यूट. स्कीमेटिक इसलिए बनाता हूं कि आपको समझ में आना चाहिए. ठीक है, base problem understood, fair bit of idea. Appliances always draw current. ठीक है, appliances draw current. अब आते हैं एक और सवाल पे, सवाल नहीं ज्ञान पे आते हैं. मिटाएं इसको, आगे बढ़े. ओके, अब बात आती है, right now the question comes is, so this much we have learned so far. Our question is, let's say I have an appliance. This is my appliance. This is my appliance. And this appliance is going to draw current. So this is going to draw current. ठीक है, मतलब इसमें कंटिन्यूअस करंट आना चाहिए. तो आपको एक सोर्स चाहिए जो इसको कंटिन्यूअस करंट देगा. In our house, the easiest way is you connect it to the wall outlets. Okay, so the wall outlets are giving you AC power, so we connect there and the current flows through it. It will become slowly more clear. So if you want to draw current right now, children, just for your understanding, ये जान के रखिए, जो current हम पढ़ रहे हैं, the type of current we are studying is a direct current. What it is, you will, if I explain also, you'll just bang your head right now. Just understand, it's a direct current means a sort of steady current. Steady current. And these are the currents that are there in all our battery devices. Battery, devices. Anything, it can be an alarm clock or anything. So this is my alarm clock. The alarm clock wants to draw current, a continuous source. So who gives you a current which is coming at a steady source? For that you need something which is known as a cell. सेल आपको क्या करेगा, आपको स्टेडी सोर्स में करंट देता रहेगा जब तक सेल कर रहा है. तो सेल में क्या होता है, सेल में हमारे पास केमिकल रिएक्शंस होते हैं. Chemical reactions convert the chemical energy to electrical energy. By the time the chemical reaction is completely over, the cell is exhausted. You have to replace it. And if you are chargeable cell, आप उल्टा करते हो, आप इलेक्ट्रिक एनर्जी देके वापस से केमिकल एनर्जी को पैदा करते हो, तो फिर देना शुरू करता है. ठीक है, ये सब आगे देखेंगे. So if an appliance wants to draw current, it has to have, these are known as steady source of current. Steady source of current. और इसका बेस्ट एग्जांपल है सेल. And a cell that is available in the market is something like this, which will have this end of the cell is always the positive terminal. This is negative terminal. Commercially available cells are 1.5 volts. Means ये volt अभी पढ़ेंगे क्या है. So this can give you a steady current, right? अब आगे देखेंगे कि ये what is the voltage, how does it relate to current. So the commercially available cells that we have, the ones that we use in our watch and all, are clocks and all are called as AA size, and the remotes and all use something called AAA. You have got 4A also, which are used in stylus pens. AAA is the patla wala, AA is the normal one that is there in that clock. AAA is the one which is in that remote control, exam patla wala. And then you have lithium cells also, which are used in. So a steady source of steady current is always a cell, and each cell is denoted in this particular format. अच्छा, इसको सिंबल में दिखाऊं तो ये ऐसा है. It is equivalent to like this. If you connect two cells like this, say another one cell I have connected here, then this is known as a series connection. Again, see, this is a series connection because you are doing ringer हो जाए, हाथ से हाथ लगा के लेके जा रहे हो. So it's similarly like I have another cell out here, and these two are connected. It's like this. Understood? Cells can be connected in parallel also. Parallel means इसका positive, इसका negative. That's parallel. ठीक है? Now the next topic, which is इसके ऊपर questions आ जाते हैं आपको, which is known as direction of electric current. अच्छा, we are studying about electric current. So far we have studied what is the formula. Electric current is a scalar quantity. हाँ, अभी आप बोलोगे sir, current has got a direction. Why is it scalar? Electric current as a quantity does not add up like vectors. The direction that we show to electric current is only either a positive or a negative. It is not like force that it can be in any angle or any direction. So electric current is a scalar quantity. अगर 1 mark question आ जाए, vector लिख के मत आ जाना, sir current has got direction. Current is a scalar quantity. ठीक है? Now comes the concept of direction of electric current. Direction of electric current. अब यहां पे थोड़ा सा आपको कंफ्यूजन होना शुरू होगा. देखिए, direction of electric current. So what did we say? What is electric current? Electric current is the flow of charges. In our case, what are the charges? The charges are electrons. ठीक है ना? तो जैसे for example, let's take a sort of a conductor. जैसे एक कंडक्टर है और इसमें करंट जा रहा है. ठीक है? Let's not put the direction right now. So what is there inside the conductor? The conductor has got electrons inside it, right? The conductor has got electrons. All the electrons are negatively charged, and we said that these are the electrons that belong to the pool of electrons, delocalized electrons. But as soon as we connect them to any cell, means they get a sort of voltage, which we will understand later. These electrons, whenever they are constituting a current, ये electrons जब भी current पैदा करती है, तो ये सब एक डायरेक्शन में चलना शुरू करती है, एक ही डायरेक्शन में चलना शुरू करती है. समझ में आया आपको? अब इलेक्ट्रॉन्स कैसे चार्ज है? किस टाइप के चार्ज है? नेगेटिव चार्ज. सो वो किस साइड जाना शुरू चाहेगा? और नहीं, लेफ्ट नहीं. एक नेगेटिव चार्ज पार्टिकल किस साइड जाना, किस चार्ज की ओर जाना शुरू करेगा? पॉजिटिव की तरफ जाना शुरू करना चाहिए. ठीक है ना? सो इट शुड गो टुवर्ड्स व्हाट वी कॉल एज द पॉजिटिव टर्मिनल, आई डोंट नो व्हाट इज दिस टर्मिनल, ये शुड गो टुवर्ड्स द पॉजिटिव टर्मिनल, और यहाँ पे जो नेगेटिव टर्मिनल है ना, वो इसको रिपेल करना चाहिए और वो ऐसे जाना चाहिए, ऐसे जाना चाहिए, ठीक है ना, दिस इज करेक्ट. This is the direction of flow of electrons. These electrons were delocalized as soon as they constitute a current. If the electrons were flowing this side, then we'll say that the positive is this side and the negative is this side, because एक नेगेटिव की तरफ तो नहीं आ सकता है, वो रिपेल होके जाएगा. थोड़ी देर के लिए जैसे एक सेल ले लेते हैं. Let's try and understand. Now this is the positive of my cell, this is the negative of my cell, right? And say I have connected a small appliance to it, a small appliance to it. Let's now try to apply the same analogy out here. There will be electrons which will be moving. So which side the electrons should move? You try and tell me. Electrons should move towards positive side. So हमारे electrons कैसे होने चाहिए? Electrons should move towards the positive side. Electron का जो movement होता है ना, the movement of electron is always known as the conventional flow of electric current. यहाँ पे थोड़ा सा confusion होगा, पहले बोलता हूँ, right? When we talk about electric current, what is the direction of flow of electric current? Let me see how much they have covered. नहीं, ऐसे नहीं करते positive negative. I'll just see whether they have covered that part in your book or not. Okay, 1 minute, huh? Because we teach later, ज़्यादा नहीं. Okay, ठीक है, चलिए. So right, so let's say we have connected it to a conductor. Now since I've connected the positive side, this is positive, this is negative, ठीक है. ये मेरा कंडक्टर का पीस है, अप्लायंस है, ये पॉजिटिव है, ये नेगेटिव है, ऐसे कनेक्टेड है, दिस कनेक्टेड टू अ सेल एंड दिस. इतना समझ में आया? Now look at, I'm trying to now draw the magnified version of this particular item. This is the positive, this is the negative. Now you tell me how the electron should move. Towards the right side, right? All the electrons should technically move towards the right side. You are absolutely correct. All the electrons should move towards the right side. Anyone has any doubt in this concept? If you don't have any doubt, then there is no issue, no doubt. Okay. However, the direction of electric current is taken just opposite to it. Electric current will be taken as moving from positive to negative. अब इसके पीछे की कहानी सुनो क्या है, ये बड़ा मजेदार कहानी है. समझ में आ रहा है? Electric current is moving this way. This is the direction of electric current. Whereas how are the electron moving? The electrons are moving in this direction. Electron. So this is the electron current. Now let me come back and explain you this thing. Concept of electricity was discovered way back in late 16th and 17th century. At that time, people had no knowledge of electrons and all. So the concept with which electrical theories were written was current flows from positive to negative. ये just एक कल्पना है और कुछ नहीं है. बेंजामिन फ्रैंकलिन वगैरह ने जब इलेक्ट्रिसिटी के साथ they did their studies and they did their experiments, those were 1600 something. तब किसी को इलेक्ट्रॉन के बारे में पता भी नहीं था. इलेक्ट्रॉन तो was discovered in 1876. So people at that time, see, now keep this in mind, okay? From the historic period, we set up something which is called a convention. ऐसा convention मान लिया गया that current always flows from positive to negative. This is a normal human being. Like say, when a child is born, you give the pen on the right hand to the child. The child may be a lefty also later on. But we think नहीं पेन तो राइट हैंड में ही दो. नहीं बहू घर में घुस रही है तो ये पांव से घुसो. ऐसा नहीं कि उस पांव से घुसने से लड़ेगी नहीं, फिर भी लड़ सकती है, या उल्टे पांव से घुसने से खराब हो जाएगा. तो दिस वाज अ कन्वेंशन व्हिच वाज टेकन, राइट? Like how do you move in a traffic signal? Once it becomes green, you start moving. We could have moved when it was red also, and when it is green we can stop. But the convention is taken that electric current goes from positive to negative. When electrons was discovered, then all the books and theories that were written, everything became garbar, because electrons move from negative to positive. ठीक है ना। तो अब हमारे पास दो रास्ते हैं, either we adopt this or we stick to this. The amount of progress that was done in theory was so much that to stick to this was considered as cumbersome, taking everything to change over. So this was given a name. This is now known as the conventional direction of electric current. And children, after this we will never study this again. Whenever we study about electric current, we go by this, that electric current flows from positive to negative. All the circuit diagrams, every appliance, every research, everything goes by this. This you will study only here and never again in your life. Again, when you study electrical engineering, maybe for 1 mark or 2 mark. So what is this known as? This is known as the direction of electron current. इलेक्ट्रॉन करंट सच्चाई में लेकिन ये करेक्ट है, इलेक्ट्रॉन्स मूव फ्रॉम नेगेटिव टू पॉजिटिव. However, the conventional direction of electric current is always taken as positive to negative. Is there any science behind it? No, no science. You actually played with electricity from 1600 something. At that time, nobody had discovered electrons. So people established some conventions that current flows from positive to negative. Based on that, a lot of research happened, many things happened. देखो, ultimately positive, negative, these are all our conceptualization. Have you seen a charge? You have not seen. You just know that two like charges repel, two unlike charges attract. वही मन घटित घटना से आप इस पूरे चीज को लेके चल रहे हो. So it doesn't make a big difference. So tomorrow, if say from 2025, Telangana government says that from now on, every green signal means stop, every red signal means move. Accident होगा कि नहीं? धाड़ धूड़ accident होगा. Somebody coming from the other state doesn't know how to drive. So नहीं चाहिए. Let us keep the original system only. So here two things हमने सीखा. In order to have a steady flow of current, you always need to have a current source. That current source generally is our wall unit that we use. हमारे television को भी current चाहिए. Or we use cells. We will now be talking at a very low voltage. मतलब ऐसा समझ लो, हम उन चीजों के बारे में बात करेंगे जहां शॉक वॉक लग के मरने का कोई चांस नहीं है. We are talking at a very low voltage. Torch light, alarm clocks, and all these things. Okay, so you connect everything to a cell. Then the next question arises: what is the direction of electric current? The conventional direction of electric current is positive to negative. Current is not a vector quantity, because current does not have other directions like force and all. It only has positive or negative. However, the particles which constitute the current, that is the electrons, they move negative to positive. And this is known as electron current. Will we study this later? No. Wrap it up and keep it just here itself. Afterwards, every circuit you will draw will be as per this. Okay? Boy is born, you give the pen in which hand? Right hand. Boy may become a left arm fast bowler also. That's बात की बात है. लेकिन अभी तो राइट हैंड में ही दे दो. यहां हम करंट को कंक्लूड करते हैं. ठीक है, एक छोटा सा फिर से क्विकली लेट्स हैव अ रिकैप ऑन करंट. वेरी इंपॉर्टेंट, नहीं तो आप फंसोगे बाद में जाके. So what is electric current? Electric current is the rate of flow of charges. That is the quantity of charge that flows past the cross section of a conductor in a unit time. एक सेकंड में कितने चार्ज निकल गए. So then a question may come, define 1 ampere. The current flowing through a conductor is said to be 1 ampere when 1 coulomb of charge flows past its cross section in a time of 1 second. So 1 ampere is equal to 1 coulomb per second. इसके बाद हमने क्या सीखा? How to measure current. Current is measured by a device called ammeter, and an ammeter is always connected in series, and it always has extremely low resistance because it should allow all the current to pass through it. Ammeter should not be a finicky child if he has come for testing food in a hostel. No, I don't eat. You should eat everything. Then only you will be able to say whether the food served is good. You are absolutely neutral, non-finicky child. सब खाओगे, सब कुछ चखेंगे, पानी, चटनी, सब चख के हम रिपोर्ट देंगे कैसा आ रहा है. ठीक है. इसके बाद हमने सीखा कि अगर आपको करंट का डायरेक्ट सोर्स चाहिए, इफ यू वांट अ स्टेडी करंट टू ऑलवेज to go through your appliance, because appliances want steady current, then in that case you should have a source of steady current. One of the easiest source of steady current is a cell. हम आगे ये चार्जर अडेप्टर सब देखेंगे, but cell is the most easiest way. सेल का हमने डायग्राम भी देखा. कमर्शियली कैसे अवेलेबल होता है और डायग्राम कैसे होता है, ठीक है। And then we understood what is the direction of electric current. The direction of electric current is always from positive to negative, and this is the conventional direction. However, the electron direction is negative to positive, but for the sake of simplicity of circuits and all, we follow the conventional one. And electric current is not a vector quantity, it's a scalar quantity. So this chapter has to discuss about three heroes, Amar, Akbar, Anthony. Amar is over. Now we come to Akbar. उसका नाम है वोल्टेज, ठीक है। अभी वोल्टेज करके नहीं पढ़ेंगे, अभी हम उस चीज को पढ़ेंगे एज इलेक्ट्रिक पोटेंशियल। थोड़ा सा बुक से अलग करके पढ़ेंगे तो आपको घूम फिर के उसी में आ जाएंगे, आपको समझ में भी आ जाएगा। इलेक्ट्रिक पोटेंशियल, the book will first explain you what is potential and then potential difference. I'll go ulta, I'll first explain you what is potential difference. Actually वही होना चाहिए। We will first understand what is electric potential difference, then we will understand what is electric potential. तो आपको देखना मजा भी आएगा, समझ में भी आएगा। इलेक्ट्रिक पोटेंशियल डिफरेंस, वो बहुत बात है, ठीक है। इलेक्ट्रिक पोटेंशियल डिफरेंस, नाउ इन ऑर्डर टू, दिस इज आवर नेक्स्ट, दिस इज द बिल्डिंग ब्लॉक टू अंडरस्टैंड व्हाट इज वोल्टेज, ओके। जैसे आप देखते हो ना, वॉल में लिखा रहता है 220 वोल्ट्स और 1.5 वोल्ट, so this is like a story, understand now. Now there are three words out here: electric, potential and difference. So we omit electric, we omit difference. First let us understand potential. ये बात हम बात करते हैं। इस बच्चे में बहुत पोटेंशियल है, देखो कॉमन सेंस है। this child, so जैसे हम बोलते हैं ना, this child has got lot of potential. यार तुम में तो पोटेंशियल नहीं है। फिजिक्स में पोटेंशियल का बड़ा अच्छा डेफिनेशन है, सेम लाइक पोटेंशियल एनर्जी जो आपने 9 में पढ़ा था। You cannot measure the exact potential of any body or system. As of now, I'm not talking electricity. You cannot measure. If I say that Aparna has a lot of potential, I cannot comment what is her potential. When I say that, say suppose this is Aparna, and I'm saying that this girl has a lot of potential. पहले इस चीज को समझो तो ही आप समझोगे, lot of potential. As I am saying these words, in my mind there is some benchmark child whom I think to be a benchmark of potential. जब ये बच्चा मेरे माइंड के बेंचमार्क चाइल्ड से ऊपर पोटेंशियल दिखाता है तो मैं इसे क्या कहता हूं, इसके अंदर तो बहुत पोटेंशियल है। आप समझ रहे हो, बड़ा रिलेटिव टर्म है। I see a child in Pebble City playing cricket and hitting 3 or 4 boundaries. बड़ा अच्छा खेलता है ये लड़का, क्योंकि मेरे दिमाग में जो दूसरा लड़का सेट है उसके मुताबिक वो अच्छा खेलता है। उसी लड़का को मैं किसी स्टेट कोच के सामने ले गया, देन स्टेट कोच बोलेगा फालतू है ये। आर यू अंडरस्टैंडिंग? इट्स रिलेटिव। सो व्हाट आई एम एवरी टाइम मेजरिंग हियर इज नथिंग बट इफ दिस वाज Aparna and if this was whatever is the benchmark child in my head, if I say Aparna has lot of potential, I am actually measuring not potential but delta potential. This is to be understood. You cannot measure because we don't know किस चीज का पोटेंशियल जीरो है, ये फिजिक्स में डिफाइंड नहीं है ठीक तरह से। Every system has some bit of energy, so you don't have something which is zero energy, so we cannot tell what is the exact potential of Aparna. Tomorrow I find another boy here called Shaurya and I would say यार जबरदस्त पोटेंशियल है यार, Aparna से भी आगे पोटेंशियल है। It's all a relative thing. So now do you understand the word potential difference? When we say so and so, the potential of so and so is say blah blah energy. It's actually a potential difference compared to something. I'll come to that. When we actually see that, when you see a 3-pin plug point at your house, you'll be seeing it's written 220 to 240 volts AC. So we say that the potential here is say 240 volts. नहीं, ये पोटेंशियल डिफरेंस है। ये 240 का मतलब क्या है? जब आप अपने टेलीविजन को कनेक्ट करते हैं, दिस इज योर टेलीविजन सेट, when the television is not connected, the television right now is at a potential of 0 volt. The difference between the television's potential means if you connect a wire out here, this television senses a potential of 240. अगर ये पहले से ही 100 वोल्ट में रहता तो ये सिर्फ 140 वोल्ट का पोटेंशियल डिफरेंस। हम लोग दुनिया में पोटेंशियल मेजर नहीं होता है, हमेशा पोटेंशियल डिफरेंस मेजर होता है। पहले उस चीज को, फिर हम समझेंगे व्हाट इज पोटेंशियल। इज दिस गेटिंग इनटू योर हेड? सो व्हेन वी से दैट, let's say in terms of work energy and power, what is the definition of potential energy? mgh, है ना? P का फॉर्मूला होता है mgh। एक ही बॉडी को एक हाइट पे रखो, एक ही बॉडी को और एक हाइट पे रखो, तो यहां ज्यादा पोटेंशियल एनर्जी है बिकॉज द हाइट इज मोर। This potential energy which you get here, let's say this height is h1, this is h2. If I say h1, this is the potential difference compared to the potential at ground, where you yourself have assigned that the potential at ground is zero. क्योंकि आपको लगता है ग्राउंड में रहने से वो कुछ नहीं कर सकता है, चीटी के ऊपर रख दो उस बॉडी को, मारा जाएगा चीटी, पोटेंशियल तो है, आपके मुताबिक नहीं है। So if we talk about potential in this chapter, always understand that we are talking in terms of potential difference. The cell that you see in Ratnadeep is written 1.5 volt compared to a body which has my clock which is at zero potential. So if I connect my clock with that particular cell, there will be a potential difference of 1.5 volts, and potential always flows from higher potential to lower potential. If you understand little bit of plumbing, then electricity becomes very easy. Electric potential is just like water. Water flows from higher to lower, आराम से आ जाता है। नीचे से ऊपर पानी जाएगा, कभी नहीं जाएगा। What do you have to do? You have to put work to it. You have to supply energy. Similarly, टीवी से पोटेंशियल जाएगा कभी भी? नहीं जाएगा। टीवी से सॉकेट को पोटेंशियल नहीं जाएगा। This is a higher potential. Therefore, current will always flow from high potential to low potential. ये देखेंगे अभी। So have you understood little bit idea of what is potential? There is nothing in physics called potential. We always, if we are saying also that the potential energy of a system is so and so, you are actually referring to the difference in potential energy, difference with respect to something. ठीक है? Potential difference समझ में आया, इलेक्ट्रिसिटी का कुछ भी समझ में नहीं आया। We just understood what is potential difference. Are you clear on this topic? There is nothing called potential. Sir, the potential of this child is a lot. No, you're saying this child based on some child which is there in your mind. अगर उस child को हटा के कोई और child ले आए ना, then this child's potential may not be the same as you're trying to commit. Just think, your school champion in terms of running, सो रहे हो, you are sleeping, Adya is sleeping, स्कूल से आगे सोते नहीं हो क्या? You have dozed off. That fellow has dozed off. ठीक है? So okay, so when you talk about showing about a child, you say this child has a potential of so and so. Then if you bring a child who has more potential, उस ज़्यादा देख लिया, then you say उसमें potential नहीं था। आप उसको potential इसलिए देखते हो क्योंकि आज तक आपने उससे ज़्यादा potential किसी को देखा नहीं है। So it's always a difference. अब बात करते हैं इलेक्ट्रिक पोटेंशियल डिफरेंस की। ठीक है, आइए इलेक्ट्रिक पोटेंशियल डिफरेंस जब भी हम बात करते हैं, नाउ यू आर टॉकिंग अबाउट इलेक्ट्रिक पोटेंशियल डिफरेंस. Difference means there should be 2 points, then only you will be able to find out difference. Potential difference between two child means at least 2 child should be required. So let's say there is a point A and there is a point B. We want to find out what is our concept of study out here is, ये थोड़ा stiff है समझना. What is the concept of electric potential difference? One way should be very easy. Sir, अगर इसका पूरा पोटेंशियल पता रहेगा और इसका पूरा पोटेंशियल पता रहेगा, दोनों को माइनस कर दो, इट शुड बी द इलेक्ट्रिक पोटेंशियल डिफरेंस. वी से एब्सोल्युटली करेक्ट, बट आई टोल्ड यू इसका एग्जैक्ट इलेक्ट्रिक पोटेंशियल आप जानते नहीं हो क्योंकि आपके पास कोई सिस्टम नहीं है जो रेफरेंस ही नहीं है जिसकी पोटेंशियल जीरो है. नाउ लेट्स गो टू अनदर स्टोरी. ओके, लेट्स से दिस इज वन समोसा शॉप एंड दिस इज वन समोसा शॉप. ठीक है, और यहाँ पे एक आदमी है. अब फूड में कैसा रहता है, वील ऑलवेज से ओ उसका ले आना, वो ज्यादा अच्छे होते हैं. तो ये समझ लें इसके समोसे में दम ज्यादा है. समोसा आप बिजनेस वाइज मुझे समझा सकते हो, हाउ डू यू से इसके समोसा में दम ज्यादा है? anyone can answer this question. Involve in discussion. Children, see, if you listen and don't participate, then how do you say? There are 3 things out here. There's a There's a B, these are two samosa shops, and there is a buyer out here. How do you understand कि A का समोसा ज्यादा टेस्टी है? हाँ. No, और आंसर सुने. Anyone? स्टोरी को रिलेट करो. मैं बताऊं आसान, मैं बताऊं, अगर ये आदमी का घर यहां है, फिर भी वो गाड़ी लेके ड्राइव करके जाके ये समोसा खरीदना चाहता है, तो इसके समोसे में कुछ तो बात है. सिंपल. तो अगर इसके समोसे का वो जो टेस्ट है, दैट इज सब्जेक्टिव समथिंग. टेस्ट को तो क्वांटिफाई नहीं कर सकते ना, तो कैसे क्वांटिफाई करें? हम क्वांटिफाई करेंगे इस आदमी के मेहनत से. देख, इसका टेस्ट इतना है कि तेरे घर के बाजू वाला आदमी भी मेरे दुकान से आके खरीद के जाता है. पेट्रोल जलाता है ना उसके लिए, फ्यूल बर्न करता है, इतना एनर्जी बर्न करता है. दैट मच इज माई पोटेंशियल दैट आई कैन स्टिल ल्योर योर नेबर टू कम टू माई शॉप. हम में पोटेंशियल ज्यादा है. बात समझ में आ रहा है? सो से सपोज देयर इज टुमारो, व्हाट हैपेंस, वी से तुम में पोटेंशियल है ही नहीं, एवरी पर्सन फ्रॉम हियर इज ईटिंग हियर. So when it comes to samosa, if you are ordering through Zomato, I am saying if somebody else is paying for it, so price is not a concern. My thing would be, I would first look at whether Karachi Bakery always gets sold out first. If anyone has a habit of buying samosa, you'll see Karachi Bakery 2:30 baje se it opens. In Zomato by 4:30 you will see Karachi Bakery sold out. Potential to hai. Everything is not price dominated. Their samosas are more costly. If price would have been the only thing, Sony Bravia TV would not have sold. iPhones would not have got sold. प्राइस सब कुछ नहीं है, पोटेंशियल तो है. आदमी ईएमआई में जाके उधारी लेके भी आईफोन खरीद रहा है, मतलब प्रोडक्ट में पोटेंशियल तो है. बात समझ में आ रहा है? इस थोड़ा इकोनॉमिक्स लाके. अब इलेक्ट्रिक पोटेंशियल डिफरेंस देखते हैं. लेट्स टॉक अबाउट इलेक्ट्रिक पोटेंशियल डिफरेंस बिटवीन दोस टू पॉइंट्स. इस आदमी को रिप्लेस करके क्या करेंगे, यहां पे एक टेस्ट चार्ज को ले आएंगे. अ टेस्ट चार्ज. टेस्ट चार्ज कैसा है? दैट भुक्कर आदमी. Understood? So we will try to see how much work you are doing for this test charge to move it from here to here. The concept of electric potential difference is something like this, that you want to measure the potential difference between A and B. So A को B को हमने initial ले लिया, initial position ले लिया, ठीक है, और A को क्या ले लिया? Final position. Okay. Remember children, in physics any difference is always final minus initial. Any difference is final minus initial. So what is electric potential difference? Electric potential difference is said to be the work done. The work done, आ गया grade 9 की बात है, to move a test charge or a unit positive charge is called a test charge. अच्छा, ये 11 12 में भी आप पढ़ोगे test charge. What is a test charge? A test charge is something which itself does not have any charge at all, infinitesimally small है. unit positive पकड़ते हैं इसको. unit positive मतलब 1 कूलम पकड़ के चलो. एक भुक्कड़ आदमी, amount of work done to move this test charge very slowly from A to B. A से B तक very slowly. In fact, in grade 12 you will understand very slowly means the charge should not take any acceleration at all. बड़ा काल्पनिक सा चीज है. Work done in moving a charge. चार्ज किसी ने कोई देखा है क्या? धीरे 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 इस चार्ज को हम B से A तक लाएंगे. We will bring it from B to A. The amount of work that you will do, charge will automatically not come. You have to do some work. That work per unit charge, कितना आपने मूव किया, is known as the electric potential difference. Yes, you have to do work. बाहर से एनर्जी देंगे, हाँ, बाहर से वर्क करेंगे. We will give a force. That definition you will see in grade 12. You will give a force with which you will start moving this charge very slowly. So electric potential, don't go with the definition now, is defined as the amount of work done. So EPE को देखते हैं. Electric potential difference is defined as the amount of work done to move the charge. Where are we moving it from? B to A. B is our initial, B to A. Work done in moving the charge from B to A per unit charge. कितना charge आप move कर रहे हो? That is that Q naught, which is the test charge. अगर 5 चार्ज मूव किए थे तो 5 से डिवाइड करोगे, हम तो एक ही से। वर्क डन पर यूनिट, वी से दिस एज वर्क डन per unit charge to move from B to A. So if somebody tells me what is the potential difference, what is the potential difference VAB, means what is the potential difference between VA and VB, I will write it as final minus initial. Final minus initial. क्लियर नहीं हुआ होगा, इसको 2-3 बार पढ़ना है, नहीं तो क्लियर नहीं होगा। चलो, don't start writing, plus try to absorb. Okay, let's start now. Understand it once again. I am myself not satisfied by your looks of your face. Okay, चलो दोबारा चलो. Let's try to understand something called electric potential difference between 2 points, say A and B. So let's first have A, and let's have a point A, and let's have a point B, right? A and B. So in terms of the potential ladder, we say that there is some point called point A and there's some point called point B. This is the potential ladder. What is the difference of potential between these 2 points? Is this confusing you? Just understand it's a potential ladder, money ladder, score ladder. It's like a ladder. Okay. Electric potential difference between 2 points. So we denote it as VAB. ठीक है, और इसको हम कैसे लिखते हैं? VA माइनस VB. ऐसा क्यों लिखते हैं? क्योंकि हम चार्ज को मूव कराएंगे B से. B will be our initial spot. ठीक है ना? It is always final minus initial. Have you understood? Final minus initial. What is VAB? VAB is the electric potential difference. What is VA? VA is potential at A, which you cannot find out, as I said, because we cannot say the exact potential of a place. What is B? Potential at B, which is your initial point. अगर ये दो पोटेंशियल पता ही होता तो सीधा डायरेक्टली माइनस कर देते हो जाता, लेकिन फिजिक्स कैनॉट गिव यू एग्जैक्ट वैल्यू ऑफ पोटेंशियल एट अ पॉइंट. व्हाट वी ऑल गेट इज पोटेंशियल डिफरेंस. अभी समझ में आ रहा है? Had we had values for this, all this Ram Kahani was not required. So how do we find out the potential difference between? It's like the same question. What is the taste of the samosa of that shop? Tasty है sir. कितना है? I want measurement. Sir, taste का तो कोई measurement आया नहीं है, पर उससे ज्यादा है. कैसे? पता नहीं सर, लोग खाते हैं. Are you understanding? I want a scientific number. Then you say, taste को कैसे number देंगे? Then we said, एक काम करो, आदमी कितना मेहनत करके उसके दुकान में आता है, उस मेहनत को assign कर देते हैं as numbers. Somebody is coming from Secunderabad to our place to have one samosa. So he is spending a lot of energy and money. We make those as some points and we assign it to our shop. And we keep on asking, where all did you get customers from? Today I got from Jubilee Hills, this. All those are your taste. Where did you get? Sir, my nearest neighbor also doesn't come and buy from me. So you don't have any points. In that way, what do? We say that we take a charge. ऐसे एक हमने charge लिया. This is known as a test charge. Test charge, like a भूखा आदमी. And a test charge has a value how much? Unit positive. Unit positive बोलो, unit means 1 coulomb, but positive, not negative. ठीक है? अभी आप सोचो, just understand. Say suppose this is a ladder in which I say this fellow is at higher potential and this fellow is at lower potential. Charge is like water. Charge will always flow from higher to lower potential. Lower to higher charge नहीं जाता है, ठीक है? तो हम क्या करेंगे, इसको यहां से यहां तक मूव कराएंगे. अभी अपने आप तो मूव नहीं होगा. You have to do some work. So we move this charge from B to A. We move it from B to A and we measure the work done. How much of work have you done? Work means what in grade 9? Energy. Work का unit joule होता है, if you remember. Work is energy. So you are trying to measure the work done to move the charge from B to A. इतना समझ में आया? B to A. And when this charge is moved, it is moved very, very slowly. This part is there in grade 12 anyway, very slowly, so that this charge should not accelerate. एकदम धीरे धीरे आना चाहिए, very slowly. You try to measure this work done and you divide it by the value of the charge whom you moved. Understood? This is said to be the difference in potential between the 2 points. This is what physics says. In other sense, I can write final minus initial is equal to WBA. कहां से कहां मूव किया? इनिशियल से, देखो कोई प्रॉब्लम नहीं है. दिस इज फाइनल, दिस इज इनिशियल. यू मूव्ड इट फ्रॉम इनिशियल टू फाइनल डिवाइडेड बाय द वैल्यू ऑफ द चार्ज. This thing is known as potential difference, electric potential difference. How do we measure it? Work will always be in joules, charge will always be in coulomb. This unit is known as volt. After Professor Alexander J. Volta, उसके नाम से volt आया है. So how do we now define electric potential difference? The electric potential difference, don't write, पहले सुनो, between 2 points is said to be the work done per unit charge or per unit test charge in moving the test charge from one point to the other. दो पॉइंटों के बीच में अगर आपको पोटेंशियल डिफरेंस मेजर करना है, we are not measuring the potential of कराची बेकरी or the potential of दिल्ली मिठाई वाला. We are measuring what is the difference in their potential. तुम्हारी टेस्ट 10 है, हमारी टेस्ट 5 है. हम क्या मेजर कर रहे हैं? 10 minus 5. 10 minus 5 is said to be the work done in moving a bhukar from one shop to the other shop divided by the weight of the bhukar. जैसा समझ लो. So electric potential difference between 2 points is said to be the work done in moving a unit positive charge. याद रखिए ये unit positive charge है. This is all काल्पनिक, मनगढ़ंत कहानियां जैसी है. Unit positive charge from one point to the other point. In such a case, the quantity would be the work divided over charge, and that is known as volt. तो अगर आप अभी आप सोचो, अब आप बोलते हो कि this is the plug point and this is the television. ठीक है, प्लग पॉइंट का वोल्टेज कितना है? 220. टेलीविजन कितना में? 0 में है. So what is the potential difference between two? 220. 220 volt is said to be the work done required to move. अभी वैसे भी चार्ज कैसे जाएगा? यहां से यहां चार्ज ट्रक से चला जाएगा. Don't you think? Charge will happily go down because this is what is known as, अच्छा इसको एक स्लोप जैसा समझ लो. This is higher potential, this is lower potential, and this is known as potential gradient. This is like water gradient. Height, less height, water will flow along the gradient. When we design bathrooms, we design bathroom with a gradient. This is called gradient or slope. So the charge will always flow from the socket to the TV. TV to socket कभी जाएगा ही नहीं. ये अमीर है, ये भिखारी है. दान कौन करता है? अमीर से. अब आप क्या कर रहे हो? यहां से चार्ज को एक्सपेरिमेंटली मूव कराने की कोशिश कर रहे हो. जाएगा क्या? नहीं जाएगा. इसीलिए आप वर्क कर रहे हो. तो इस वर्क को हम बोलते हैं external work. You have to do this work externally in moving, because you tell me what should be the value you should get as the potential difference? 220. not minus, positive. Who is at higher potential? This fellow. This fellow is at 0. In order to get 220 positive, you should do 0 minus 220 or 220 minus 0. 220 minus 0. That means who should be the final point? Who should be the initial point? Will the charge go from 0 to 220? Never. Who wants to leave? नहीं जाएगा. तो कैसा होगा? आपको externally work करना होगा. You have to, it's like pushing the charge up the gradient. That external work per unit charge, it's like moving 5 kids from bottom to top. How much work per kid? Sir, I spent 20 joules. There were 5 kids. So 20 divided by 5, I'm spending 4 joule per kid. But in our experiment, we did not bring 5 children. We brought 1 child only. So there is no question. So we say the potential difference between 2 points is defined as the external work done to move a unit positive charge across the 2 points. That's the potential difference. अब हम लिखेंगे इसको. ये चीज समझ में आया? I don't know how much you had. Anyone has any queries? You all don't have queries. That skills me more. This cannot be absorbed so quickly also. No one has a query. हाँ, potential gradient. Okay. चलो फिर से एक बार देखते हैं. जब तक नहीं, ऐसे बुक में तो एक डेफिनेशन लिखा रहेगा, आप वो डेफिनेशन पढ़ के कुछ भी नहीं समझोगे. आ जाओ. Gradient. Gradient means any sort of slope. Understood? You can have gradient. Economic abilities gradient. My earnings are here, your earning is here. This is a gradient. Gradient. Potential gradient means, let's say this is a point A, this is a point B. This is the potential called VA, this is the potential called VB. This is the gradient. Means they are not equal. दोनों में एक फर्क है. So whenever there will be a gradient, assume like water, the water will flow down. Suppose this was a higher building and this was a lesser height building, water will flow down this way. So in case of potential gradient, what flows down is known as charge. A charge will happily flow from higher potential to lower potential. It cannot flow from lower potential to higher potential. Just imagine my refrigerator out there, it is not connected, it's at 0 potential. If charges were flowing from it, then सारे बंद रेफ्रिजरेटर से लोगों को पावर मिल जाता था. हो सकता है क्या? नहीं हो सकता है. So this way the charge will never move, but one way it can move. If you do some work on it, it will move. Imagine a stone kept here. The stone will roll down. That's what we studied in work energy power in grade 9. Higher potential से lower potential, पानी ऊपर से नीचे अपने आप आ जाता है. नीचे से पानी ऊपर जाता है? नहीं, आपको पंप लगाना पड़ता है. What is a pump? A pump is a device which consumes energy. That means you are giving energy to the system. Then only system will do work. अभी आप ऊपर से पानी स्टोन पानी रखो और नीचे शौर्य को रखो, गिरेगा ना पानी उसके ऊपर. नीचे से पानी ऊपर जाएगा, पर जाता है ना, पंप लगाना पड़ता है. उसको लगाने के लिए पैसा खर्चा होता है. So energy goes. Have you understood? Every time you are actually, then something every night, what happens? Look at this one. This is temperature gradient, TA, TB. On a hot summer day, how is it? Sir, this is my room and this is outside. So what will come here? Sir, heat will come here. So heat तुम्हारे room में आना चाहिए, but you sleep very comfortably by pushing heat on the opposite direction. How is that possible? You are running an AC, you are supplying energy, then only heat will move. Otherwise, heat will always flow in. Take any hot substance, bring a cold substance to it. The hotter substance temperature reduces, the cooler substance becomes more hot. Cup of Bonvita made by your mother just before going to school, and you start shouting, "Abhi main nahi pee sakta hu, garam hai." She puts it up in a tumbler. So what happens? इसका temperature नीचे आ जाता है, इसका temperature बढ़ जाता है. उल्टा कभी होता है क्या? ठंडा पानी में बोर्नविटा रखने के बाद बोर्नविटा और गर्म होता है क्या? नहीं. पर सर, हमारे घर में ना फिलिप्स का एक जग है ऐसे, उस जग में हम पानी भर के जब करंट में लगा देते हैं, ठंडा पानी गर्म हो जाता है क्योंकि वो एनर्जी पी रहा है। अब क्लियर हुआ आपको? ठीक है, अब अगर ये क्लियर हुआ है, आइए अब हम लिखते हैं व्हाट इज पोटेंशियल डिफरेंस और इलेक्ट्रिक पोटेंशियल डिफरेंस। सो we'll write together. The electric potential difference, I will write once like this, afterwards I'll use the word PD is what it is used as, the electric potential difference। और थोड़ा आगे जाके इस चैप्टर में सुनो बच्चों, we'll have a convention here, first time I am writing electric potential difference, henceforth I will use the word PD, that's how the chapter goes, and slowly this E will not be spoken of. You are in the chapter of electricity, so every potential difference is the electric potential difference. We are not talking about your stamina, your vigor, vitality potential, or potential in terms of your playing cricket wicket, wo sab nahi is electric potential, auto understood. So the electric potential difference between 2 points is defined as the amount of external work done per unit charge in moving a test charge across the 2 points. Or you can also write in moving a charge, in moving the test charge from one point to the other, or moving the test charge across the 2 points. Okay? Now we go by our definition and we try to schematize it. So electric potential difference between 2 points, कौन से हमारे points होंगे? A and B. ठीक है, आइए इसको बनाते हैं. This is A and this is B. The electric potential difference between 2 points. So how do we write it? We write this as VAB, which is said to be V of A minus V of B. अच्छा, convention बड़ा easy है, आप गड़बड़ नहीं कर सकते हो. VAB you are writing as V of A minus V of B. Always it will be final minus initial. तो ये final है, ये initial है, ठीक है ना? If that be the case, that means this is initial. Agreed? No confusion. This is final. So how should our charge move? Our charge should move from here to here. Final is initial. So amount of work done. Now it's defined as the amount of external work done. So what is the work done? To move it. WEXT in moving from B to A. Amount of external work done per unit charge. So we will write VAB is equal to VA minus VB, which is equal to amount of external work done in moving the charge from B to A per unit charge. Per unit charge. So whom are we moving? We are moving a unit positive charge Q per unit charge. Okay? This is expressed in joules because this is energy and this is in coulomb. And this unit is known as volt. So 1 volt is equal to 1 joule over 1 coulomb. ठीक है? अब इसका इजी डेफिनेशन भी करना है हमें. ये तो हो गया पोटेंशियल डिफरेंस बिटवीन 2 पॉइंट्स. क्लियर है? The book studies this later, but now we will study what is electric potential at a point. Electric potential, and this is where you will really enjoy now. Potential at a point. So we don't change our story anything. Our at a point, this at a point, we assume that point to be A. Now we are being very selfish. We want to just find out what is the potential at A. Exact potential. Do we have a system? No, but we will create a system. ठीक है। सो वी नाउ वांट टू मेजर व्हाट इज VA, हमें VA चाहिए। सर क्लास के स्टार्टिंग से आप बोल रहे हो VA तो मेजर ही नहीं हो सकता है, लेकिन जुगाड़ लगाना पड़ेगा। कैसे जुगाड़ लगाएंगे? इसी एक्सप्रेशन से करेंगे। जरा सोचो, VAB is equal to VA minus VB. What am I interested in finding out? VA। किसी ना किसी तरीके से इसको अगर 0 कर दूं तो VA मिल जाएगा। देखो मैथमेटिक्स है, इंटरेस्ट लो यहां पे। इसको अगर 0 कर दूं तो वी विल गेट VA। yes or no? VA we cannot find out, but we still want VA, so इसको 0 करना पड़ेगा। But we say, सर कैसे 0 करोगे? इस पॉइंट पे भी तो some potential is there. Every point has some potential. Now here is where the assumption part of physics comes. We define a location, we define a new location here, and that new location is called infinity. कहां है? बहुत दूर है। कितना दूर? पता ही नहीं। इंफिनिटी वो जगह है जहां एक सिस्टम का पोटेंशियल 0 है। That means in our new concept we will be moving the charge from infinity to A, and we will measure the external work done to move the charge from infinity to A. And what do I write? I write same VA infinity is equal to VA minus V infinity. Same concept, which should be equal to W external in moving from infinity to A divided by Q. But sir, V infinity has been assigned the value 0. So VA is equal to W external infinity to A divided by Q. Your book will first discuss this and then this. It is better to understand this and then come to this. How do you get the potential at a particular place? We get the potential at a particular place by moving the charge now not from any B, C, D, but moving it from infinity. Sir, why did you select infinity? Because at infinity the potential is taken to be 0. अब जरा एक और एग्जांपल सुनो तो और अच्छा समझ में आएगा। It will get, see, I am from my heart, I am done with this topic nicely. I am still not done with this topic. Huh? If required, we will again next class start from here. But listen, one more thing. This is me. I am a dangerous दादा। मेरे से सब डरते हैं, सामने कोई नहीं आता है। ये है मेरा इनर जोन सर्कल। यहां किसी के आने की मजाल है? This is in and around titanium. My दादागिरी works. This is high-tech city, but still I am a dada. I'm still known here also. You can feel my dadagiri. I'm at Mumbai now. This is Mumbai. अरे सुना है हैदराबाद में एक दादा है जयदीप दास, पर वहां मेरे डर से कोई काम नहीं करोगे क्या? कर लोगे। डू यू एक्सपेक्ट कि मैं बॉम्बे जाके तुमको पीट के आऊंगा? ऐसा नहीं। बट मैथमेटिकली आई एम रेडिएटिंग व्हाट? डर। तो मेरा डर यहां पे स्ट्रॉन्गर है, यहां थोड़ा वीक है, यहां और वीक है। एंड से दिस इज सियाटल, अमेरिका। मैथमेटिकली वहां भी मेरा कुछ तो दादागिरी है, पर ऐसा थोड़ी है अरे अरे बाहर मत निकलो जयदीप आके पीट के जाएगा। अरे जयदीप इज इन हैदराबाद, बट मैथमेटिकली आई स्टिल हैव सम दादागिरी। This is Venus. I still have mathematically some dadagiri, though that dadagiri is almost negligible. Understood? Infinity. This is a place where even the gods have said that JD's dadagiri here is 0. Mathematically also there is no dadagiri felt out here. Now just take out JD's dadagiri and go by potential. Potential at this point and potential at this point. हर जगह कम होते 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 जितना हम पास आएंगे हम ज्यादा पोटेंशियल के पास आएंगे। इलेक्ट्रिक पोटेंशियल इज नथिंग बट द ऑरा दैट सम ऑल दीज यू सी ना, जैसे आपके आजकल गुरुओं की तो कमी नहीं है, आप चैनल खोलो, एवरीवन इज अ गुरु, प्रवचन देता है, but in and around every guru there is an aura, so his potential is to some area. But if you talk about this guru to some place in Kashmir, कौन सा गुरु बात किया, टीवी में आता है क्या, बट उसका ऑरा शायद वहां तक है, आप फील नहीं कर रहे हो. So when we say what is the electric potential at a particular point, then we don't move the charge from B, we move the charge from a very far off point which is infinity, and we will measure the work done. बंद कर लिया आपने, डेफिनेशन लिखा नहीं है. So what is, हाँ इसका डेफिनेशन नहीं हुआ ना, what is electric potential at a point? Can you now write this definition? It will be just like that. The electric potential at a point, can anyone define it? Try to define. See, in schools we used to do that. Try to define, looking at this and the whole story. How would you define? The electric potential at a point is defined as the amount of external work per unit charge done in moving a unit charge from infinity to that point. Yes, from infinity to that point. और ऐसा आपने क्यों किया? I hope you understand this mathematical relation which I tried to draw. The mathematical relation is simple. Potential difference between A and infinity is given as VA minus V infinity, which is equal to external work done in moving from infinity to A divided by Q. By convention, this value is 0. So our VA's value becomes W external infinity to A by Q. और इनको circles में रखिए. Two formulas you need to put in rectangular block holes. One of the formula would be potential difference between 2 points, VA minus VB is equal to W external B to A divided by Q, and VA potential at a point is W external infinity to A divided by Q. These are 2 points. But from these 2 points, we get only one definition, that potential difference V, this is what we will use. This is what we will use for doing numericals, is always given as work done over charge. Volt is equal to joule over coulomb. So we have one more definition, 1 volt. The potential at a point is said to be 1 volt. No. You cannot define potential of a point. So we say the potential difference between 2 points is said to be 1 volt if 1 joule of external work is spent in moving a charge of 1 coulomb between the 2 points. Between the 2 points, or one point to another, as you say. आप समझ रहे हो? 1 volt is said to be the potential at a point. In entire physics, all we understand is PD. P नाम का चीज है ही नहीं. PD. The potential of Adya, the potential difference of Adya is said to be so many caliber as compared to the mindset वाला बच्चा that I have. उसके comparison में हम आपकी potential measure ही नहीं कर सकते. So the potential, so this is what 1 volt is said to be the PD between 2 points if you are spending 1 joule of work to move a charge of 1 coulomb. So this is your numerical wala formula. ये से ये आता है. So by now you have 2 formulas of 13 formulas. I is equal to Q by T, V is equal to J by C. अब यहाँ पे थोड़ा C को और I को घुसा सकते हो. V is equal to J by C. C क्या होता है बेटा? हाँ, कैसा होता है? I is equal to Q by T. मतलब ये हो गया J by Q है. J, हाँ. So this is equal to W upon Q. ठीक है? So volt is equal to W upon Q. What is the value of Q? Q is I into T. Very good. So V is equal to W by I into T. Do you get it? Q is equal to I into T. हाँ, अभी वर्क डन का फॉर्मूला कैसा आ गया आपका? वर्क डन बाय टाइम का फॉर्मूला कैसा आ गया? V into I आ गया आपका. Do you remember this quantity from grade 9 physics? Work is joule. Rate of doing work is known as power. This is another formula which will come. Power is equal to VI. काम करने की क्षमता को हम कहते हैं पावर. She can do a work in less time. ज्यादा पावरफुल है. आप ज्यादा टाइम में ये काम करते हो, लेस पावरफुल हो. अगर ये कॉन्सेप्ट्स क्लियर नहीं हुए, that's why you can't forget last time. Power is power, whether it's mechanical power or this. In our next class, we continue from this part. But now if you don't study and come, आप कुछ नहीं सीखोगे. लेकिन बार बार बोलता हूं मैं, ठीक है?